All right, I'm going to share my screen. All right, can everybody see my screen?
Yes.
I'm going to share my screen. All right. Oh, not too. Bring that over. And let me open up the chat. All right, excellent. Welcome. All right, so so a reminder of what we're doing this week. This last week, this is the last full week that we are together, and so my plan was to cover some topics that might be useful for the project, and also discuss the project-related assignments such as P1, P2, and give everybody a chance to discuss any challenges or any questions that may have for the final project. And if if absolutely no one has any questions, I do have a couple more topics that I'd like to discuss. In particular, Firebase. We discussed MongoDB as an alternative to relational databases. That allows us to dip our toes into the non-relational database world. And Firebase is quickly becoming a great alternative and very popular amongst developers for creating prototypes. I mean, full scale applications, but being so simple to set up and throw some data there and make it available to applications and integrate with all sorts of types of clients. It's become a great choice for putting together an application very quickly. So I'd like to discuss that perhaps towards the end of today's lecture. But before we get into any specific topic, I was hoping that folks might have questions about the project that they're working on. And I see that I'm getting a lot of questions on Piazza, and also private questions that on email or texting me, and these are all great questions that perhaps other folks might have the same questions. I'd love for you to give you a chance to discuss this. So I'd like to open the floor for anybody who might have a question or challenge or whatnot that we might cover here. Now, if it's something that's super duper specific to your particular problem, then I might ask you to that we could deal with this offline, especially if it's something about a bug or some configuration. Definitely, we can discuss that afterwards. But if it's something about a design, or maybe you want to go over a UML class diagram, or how to implement your UML diagram as a relational database or non-relational database, or implementing enumerated data types or inheritance, or any design, whether to use primary keys, foreign keys, whether to use something either unique or whatnot. So yeah, I'd like to give you a chance to discuss those kinds of questions for everybody. Yeah, so having said that, let's see, looks like somebody has posted a question in the chat. Let's take a look at. For the UI, what are the requirements? What are you looking for when creating the UI and the interactions? So the requirements, let's see, let me see what this is. So the requirements say the following for the UI. So first of all, it doesn't have to be anything fancy, right? So don't Don't waste time trying to make it look really fancy. It can be very just functional, right? That it just allows you to interact with the database. But here's just an example on what we expect, right? So say you have 3 tables. Okay, you have a student table, a course table, and a section. So remember, the requirements say that that you have to have at least one class diagram that represents a human. So there's students, for instance. Students represents a human. And then 2 classes that represent non-humans, what I call domain objects, right? These are objects, right, that you would encounter in a particular domain or particular topic. Like, for instance, if my topic is education, then a human being in the education topic or domain is a student or faculty, right? So students is what I chose. And the domain objects in the education space then would be courses and sections. So again, one human and 2 non-humans, right? So that's one of the minimum requirements. Obviously, you can have more human users, right, and more than 2 domain objects, but this is the minimum. Now, for each one, we're expecting that there should be at least 2 screens per table. Okay, so for instance, for the student, there should be 1 screen where I can see the list of all the students. And there should be at least 1 screen that allows me to edit a particular record, right? Now, we've given you examples on how to do that with React.js. I believe it was the web, there was a web topic, right, that we covered about a month ago, where I showed you, right, so here's a couple of tables, and let's edit. I think it was a users. It was a users table. There was a blogs table, I believe, right? And then I asked you to do the posts on your own, right? So for the student table, there should be 2 screens. One that allows you to just list all the users, and the other one that allows you to edit a specific user, a specific student. Same thing for the courses. For the courses, there should be 1 screen that lets you look at the content of the course table, and 1 that allows you to edit a specific course. Okay, and then same thing for sections, and for 1 that allows you to list all the sections, and the 1 that allows you to edit a specific section. Okay. Now, that's for listing or editing. So listing all the records and editing a specific record. Yes, but getting a little bit into the nitty-gritty, there's also relationships between these tables, right? So for instance, right, a course might be related to many sections, right? So if you have many sections, usually there's a one-to-many relationship between a course and a section. So if you have that, right, if you have the a one-to-many between course and section, well, you should be able to represent that, right? That if you're looking at a list of sections, well, that list of sections could be 3 different things. It could be the list of all sections. It could be the list of the sections that are related to a course, right? So that would mean that that's a subset of the sections, not all of them, only the sections for a particular course. It could also be the sections related to a particular student, right? Those sections that I am enrolled in. Okay, so there it is. So the section list could be either the list of all sections, or it could be the sections a student is enrolled in, or it could be the sections for a given course. Again, it depends what you're doing, right? It's up to you. to use these appropriately. Same thing for a student. There's a many-to-many relationship between a student and a section, right? One student can be in many sections, but one section can have many students. So a list of students can be either a list of all the students, right? Or it could be the list of the students given a particular section. Right? If you give me the section, I would like to list all the students in that section. Again, this is relevant to you, whatever, however you're implementing it. But these are suggestions on the kinds of user interfaces that you would need. Now, the TA or myself, right? You're going to have to demonstrate to us. You're going to have to demonstrate that you implemented a user to domain object relationship. Right? You're going to have to demonstrate it, and the only way to demonstrate it is that if you have, for instance, between user and section, for instance, that a student. So an example of a user to domain object relationship is user to section. That's a user to domain object. A student to a section is an example of a user to domain object relationship. Yes. Now, in our case, we have a many-to-many, right? Student in many sections, many students in many sections. So we're going to ask you to demonstrate to us that you implemented this. So we're going to ask you, okay, well, using your application, demonstrate to us that you have implemented user to domain object relationship. Okay, so your demonstration might be, okay, I'm going to, for instance, I navigate to a student, and from that student, I can now also select, maybe there's a link or something or button where I can see the sections that that student is enrolled in. And I click that, and it navigates to the list of sections that that student is enrolled in. And then you can say, there you go. You can totally see that Alice is enrolled in section 3 and section 5. And vice versa. Now that I'm showing a particular section, I can say, well, now that I'm in that section, notice I have a link that says students. But if you click on that student or that link, it takes you back to the list of students, which you can show that those are the students for that section. So if I'm in section 5 and I click on students, I can totally see that Alice is enrolled in section 5. Yes, so that's user to domain, and that's how you're going to demonstrate to us that you implemented that. Then we're going to ask you, demonstrate to us that you have a domain to domain relationship, right? Well, then you would show it to us using courses and sections, right? We said that there is a one-to-many relationship between courses. One course has many sections. And the way you're going to demonstrate to us, you're going to say, well, I'm going to go into an editor, into a course, and in that course, I'm going to have a button that says, show me the sections for that course. If I click on that course, on that button, it'll navigate to me all the sections for that particular course. Right? If I have, course 3200, and I go into my course 3200, right? I can totally see that I am teaching two sections of 3200, section 3 and section 4. And some other professor is teaching sections 1 and 2. And some other professor is teaching 5 and 6. Okay, so this course has many sections enrolled, right? Many sections for that particular course. So that's what the user interface should be able to do. Did that answer your question, Luke?
Yeah. I have a follow-up question. So for these lists, we can just render in HTML as like an on order list. That'll be okay.
Say again. You can on order list. You said.
Yeah, we render as an on order list.
Sure.
Okay.
Yeah, it doesn't have to look pretty. I gave you some examples on how to make it pretty using Bootstrap, blah, blah. Not required, right? It has to just demonstrate that you have implemented the feature.
Okay, thank you.
Yeah. All right, so this is a question on the chat. It says, hey, professor, what additional work do we have to do for P3 of the project? So P3, yeah, no, P3 is just the actual implementation. So it's just a placeholder for you to submit whatever you have completed for the project. There's no additional, just finish it off, just complete it, and you will submit the project. So it's just a placeholder for you to submit your final deliverables. So yeah, no. So basically, P1 is these are mostly placeholders for for you to measure yourself on where you should be, right? By the end of this week, you should have a design and the beginnings of a database, right? And it is okay that the design is not completed. It is okay that maybe by the end of next week you realize that your design is missing something, right? That it's missing a field, or it's an incorrect data type, right? That you should have declared a float instead of an integer. You might realize that you need actually another table. You might realize that you need another mapping table to do a many-to-many, and you don't know that yet, right? So it is okay by the end of this week, this Friday, that you have a preliminary design. You have what it looks like a user model, and you have two domain objects. You have a couple of one-to-manys and many-to-manys, but it's totally okay, right? With realizing by the end of next week, it says, ooh, you know what? I should have need this, that, and the other. Let me make those changes. Let me go back and add a table or add a class or rename something, right? It's very, very common in industry that you do that. Same thing with when again, by the end of this week, you should have also the SQL create statements, right? That create all those tables. And it's not uncommon that by the end of next week you realize that, oh, I need another table, right? Or I don't really need this table, and you throw that away. And so even though P2 here just focuses on user interface and object relational mapping and whatnot, you might find yourself that, ooh, you might need some more tables and whatnot. So it is okay. So it doesn't have to be completed entirely by the end of this week, right? There's some wiggle room, and we absolutely expect you to come back and revisit that. Okay. But by the end of next week, you should get going implementing some user interface, right? On creating some code that actually connects to your database and starts interacting with it, right? That you can retrieve data from the database, you can send data to the database, you can update database, delete, right? You should start implementing that as well. So hopefully by the end of next week, you should have that going. So there's a question. P3, yeah. So there's nothing new for P3. P3 is just basically wrapping up the project. So that last week, by the 26th, you should have a working project. Do we have to show the changes to the database inside of our UI as well? Yes. For example, display user count. Well, I mean, yes, you can display user count, but if the user interface says that you're deleting a user, well, then the interface should show that user doesn't exist anymore, right? Again, it doesn't have to be fancy, right? If say you have a user, that's listing a whole bunch of users, and you click on delete, right? The fancy thing would be to show that row just disappears, right? I mean, that's pretty cool, right? That's what you would expect that a user interface would do. But again, we don't want to get fancy. I don't want you to waste time on if instead you can show that the user is gone by by refreshing the screen somehow and say, oh look, I'm gonna query the database and realize that that record doesn't exist anymore, and then I'll just re-render. And then if you can demonstrate, look, it's gone, the user is now not there anymore, then that's plenty. Don't waste time on saying, oh, why is my UI is not re-updating. That's a web, or that's a iOS or Android, whatever infrastructure you're using. Okay, that's a UI issue that I don't want you wasting time on that. Okay, I want you to focus on the database part and not get too bogged down on UI stuff. That answer the question?
Yeah, thank you.
All right. Anything else? Let me share a couple of questions that I had from the other section that might be useful here. So one of the requirements is that your enumerated data types they should be implemented using portable enums. Okay. Perhaps I should make it explicit here. Implement at least one portable unit enumeration. Okay, I'll make it explicit here. Do not use MySQL's enum keyword. Okay. Okay. So yeah. So let me demonstrate what I mean by that. We did talk about it a little bit halfway through the course when we were looking at enumerated data types, but let me demonstrate what I mean. So for instance, if you have let's see, okay, we have assignments here. Okay, let's use your another database here for schema. Okay, and so say you have here say you have movies, right? A table called movies where you list all your movies, all your favorite movies. Okay, and you have something like this. You have let me just copy this, right? So this is movies or movie, and you have maybe a title, you have a plot, you have director, whatever, okay? And you have genre. And that genre, you want to represent it as a string, right? That means that genre could be, valid values for that genre should be whether it's horror, sci-fi, right, fantasy, comedy, drama, whatever, right? So now if you leave it alone just as a string, then you're not enforcing anything about that. You're not putting any constraints on the values of that string. And for the most part, that might be totally fine for you, but it's error prone, and it could introduce some bugs that could be very hard to find and debug. So as much as we want, as much as we can, we want to strong type things and add constraints that disallow inserting bad data. So instead of just saying a string, then ideally this would be from a data type, called genre, which now adds constraint to this, right? And so the implementation of that would be that there would be presumably an enumerated data type called genre that lists all the valid values for that genre, right? And let me show you how you would implement that. So the way you would implement it would be with an enumerated data type. Okay, and we're going to call it This is enumeration, and it's a genre enumeration data type. Okay, and let's remove all this from here. So in here, the genre is not a class, right? It's not an interface. It's an enumeration. Right? It's its own thing. Even though it looks like a class, it looks like an interface, it's not, right? Meaning that here, these are actual fields, right? These are columns. These are properties of an object. Here, what you list here, these are not properties, right? They are the valid values. What are the valid values for genre? Well, it could be horror, it could be comedy, right? It could be sci-fi, right? It could be drama. So these are all the valid values for the data type genre. Okay, and by saying that this genre variable is of type genre, that means that the genre variable can only possibly have these values. Okay, now this is not a uncommon thing to do. I mean, you do it all the time. Say you have, you have how many likes? How many likes has this movie had? And you say this is an integer. An integer is an example of an enumerated data type. It's a very big enumerated data type with a lot of enumerations, right? And you use it all the time, right? It could be implemented as follows. It's an enumeration, and it's an integer. And the values go from -infinity, right? Going all the way through, right? All the way to -4, -3, right? -2, -1, 0, 1, 2, 3, all the way to plus infinity. So so integer is an enumerated data type, and we're constraining these likes to being one of these values, right? What we're saying is that the likes cannot have values such as yes, no, true, false, right? It could not be a string, cannot be a varchar, right? It cannot be any character. Only the possible symbols that could be assigned to the integer variable can only be taken from this infinite enumeration. Yes? So similarly, genre, we're saying that the data type is genre, so the only possible symbols that genre can take are taken from this subset. That makes sense? And so just like -4 and -3 and -2, those are not columns, those are not fields, they're just a list of all the valid values. In that way, also the genre enumeration, these are just values. Okay, they're not fields, they're not properties, they're just values, symbols. Just like -4 is a symbol, comedy is a symbol. Everybody okay? All right. So how you would implement this, in MySQL, you can say genre is an enum, but I'm asking you not to do that. And the way you would implement this instead is that you would create here, a table called genre, or maybe movie genres, okay? And the column might be genre, and it's a varchar, maybe 45 characters long. It's primary key, and it's not null. And we say apply. Okay, and then you would insert here all the valid values for that genre. You would say, well, you have horror, maybe all caps, horror. We implement comedy. We implement sci-fi. We implement drama. So these are all the valid values. Let's apply and insert. Okay, so now to implement the movie, we want to basically say that the field genre is constrained. We want it to be a string, but we don't want it to be any string. It could be only a string from here. So the way we can implement that and we can enforce genre to only have values from here is by declaring these primary keys and declaring genre a foreign key into that table, to that field. That way, because it's a foreign key, right, the database is going to enforce what we refer to as the referential integrity, meaning the value from this foreign key, right, can only refer to a primary key that actually exists. Right? So if genre is going to have a value, it can only be from a valid primary key. You can't just put any string, right? If it's going to be a string, it has to refer to a string that exists as a primary key in another field, in another table. So to implement that, the table, we can say add table, and this is movies. And it can have all the fields that you would expect, right? You can have maybe ID, which is an integer, maybe auto incremented. You can have title as a varchar, and 255. It's non-constrained, so the title can be anything. You can have a plot, right? So maybe it's something a little bigger. You can have a director. You can have a genre here. So here's where, right, we can just say genre and not constrain it. This might be likes, and it's an integer. Okay, notice that we have not constrained genre. We're just saying it's a string. Okay, so we apply that. We go back and start inserting data. Because it's not constrained, we can type whatever we want for genre. All right, so this might be, aliens, director James Cameron, and so the genre, I don't know, is it horror or is it sci-fi? I'll say horror for now. So that genre is fine, right? And maybe 1 million likes. So if you apply that, right, it doesn't complain, just horror. Okay, but say I insert, maybe Lord of the Rings or something, Lord of the Rings. And so, what's his name? Who directed Lord of the Rings? I forget his name. Jackson. And so I put the genre here and say it's fantasy or whatever, fantasy. Okay, and 2 million likes. And I do an insert. Notice that it allows me to insert the genre even though it's not a valid enumeration in my enumerated data type. See that? So it totally let me insert it. Notice that if I refresh, the data is there perfectly fine. So I would want the database to stop me from mistakenly choosing a genre that doesn't exist. All right, so let me try that again, right? So let me remove that and delete. Okay, so if instead I go back and I edit my movies and I say that the genre, I want to have a foreign key that says that I want to constrain that variable, that field, so that it can only be for a certain set of values. Right? I want just the database to stop me if I use the wrong value. Okay, so for instance, I can say that this is an enumerated genre. Okay, I'm going to reference the movie genres. I'm going to say that the genre field can only possibly take values from this table, the movie genres, into that field, right? The primary key, which is also called a genre. And we say apply. So notice that this is going to add the constraint that says that now, okay, the movies table, the field genre is going to be a foreign key into the movies genre table, into the primary key genre. That means that now, if I enter there a value that is not in the primary key, it's going to stop me because I am using a value that is not sanctioned, right? So I say apply. So now if I go back, and to my movies, right? If we go back to my movies and I try to insert, right? Again, same thing, Lord of the Rings and Jackson. And I say that this is fantasy, okay, and 3 million likes, and I say apply, okay. Notice that if I apply now, the database stops me and says, no, you are breaking referential integrity. You're trying to insert the valid value for the genre, okay. So that if I refresh, notice that the record was not inserted, okay. But if I go into my movie genres and I insert it as a valid value, fantasy, say apply, now it's valid, and I go back to my movies and I try to insert now Lord of the Rings, Peter Jackson, right? And I insert fantasy, and say apply, right? Notice that this time it's okay, right? So there we go. So we basically constrained. Oh yeah, thank you, Sidar. Notice that we've constrained the value of that field genre, just like, it behaves just like a enumerated data type, right? It stops me from inserting bad data in there, right? And that's what I meant by enumerated data type. Okay. Anyway, that was a good question from the other section. I'd like to give a chance for folks, if you have other questions, love to discuss this here with everyone.
What's the difference between what you did and portable enumeration?
Oh no, this is portable enumeration.
Okay.
This is how you implement a. What I mean by portable enumeration is that this can be implemented just like what we did. It can be implemented in any database, right? You can implement the same thing in SQL Server, in Oracle, Postgre, as opposed to if you use enums. If you use enums in MySQL, they might not be fully implemented in other databases. So it's not portable, right? So you implement your tables, you do all your SQL statements and create them. You create your tables, but that same SQL that created your table in MySQL is now not portable to other databases. So that's why I'm saying stay away from MySQL enum. Obviously, if you can guarantee that your organization, the company that you're working for, is only ever going to use MySQL and they're not going to want to go anywhere ever, then it might be okay for you to use enums, and that's totally fine, right? But it has to be a deliberate decision, right? It needs to be a design decision, as opposed to, oh, let's just use enums, and you choose that lightly. All right. Any other question? All right. So there are no questions. I would love to get chatting about Firebase. Is that okay with everyone? Unless anyone has any other questions. All right, let's chat about Firebase. Okay, so Firebase. So Firebase is one of several non-relational databases that are becoming very, very popular. It's as an alternative to not to relational databases. And we saw last week, was it last week? Yeah, we were discussing MongoDB as a non-relational database that is an alternative to MySQL or Postgre or SQL Server, Oracle, right? All those are relational database solutions, and these are an ever wider choice of non-relational databases that are challenging relational databases. Okay, and this one in particular has quite a few features that are very, very popular amongst developers. It makes it very, very easy to get started and create an application in minutes. Get started in inserting data and creating a means to start interacting with the database with minimal work, right? In particular, it addresses one of the bigger challenges when designing applications, is that the classical way of implementing application is that you have multi-tiered applications, right? Where you have two extremes, right? On the one side, you have the user, right? And presumably they are using some kind of interface, right? Whether it's command line, whether it's a phone or a tablet, or some kind of UI, right? Some web or some desktop application. And then on the other side, you have the data. You have a database that is storing data in a whole bunch of tables and records and related to one another. And you have to build in the middle, right? You have to build a middle tier, right? The thing that sits in between the data and the user. You have to build something that understands all the human gestures, right? As they type the keys and they drag the mouse and whatever gestures they generate, they type with their finger sticks, right, at the keyboard. And you have to convert all those gestures into SQL or non-relational commands that insert data or delete data or update data. So you have to do that conversion between the two. The data comes in, right, or an event, a stream of events comes in that gets converted into a stream of database updates, inserts, deletes, and then data comes back that gets read and then rendered in some kind of graphical representation in some tabular format or whatever, right? And you have to build the thing in the middle. Now, that thing in the middle has a lot of things, a lot of responsibilities, okay? One of the responsibilities is that it needs to be able to participate in communication, right? It needs to be able to participate in some kind of network, right? Where this user can send these commands over some network, and then that middle tier needs to network, connect to some database and extract the data. So that's one of the challenges. The other challenge is that it needs to enforce that the correct person has access to the correct data, right? It needs to enforce authentication. It needs to enforce authorization, right? That a faculty, when they log in, they can change the grades for their course, but not change somebody else's grades from some other course, right? So it needs to be able to enforce, first identify who you are. It says, okay, I know who you are, right? That's authentication. But it also needs to be able to enforce authorization, right? And says, okay, well, now that I know who you are, right, I need to be able to say, oh, well, you can do these things, but not these other things. So authentication, authorization. It also needs to deal with the fact that since it's living in a networked environment, those environments might not be always available, right? Like for today, I lost network communication and I wasn't able to right, start my class on time. I need to wait for my network to come up. So these things happen, and so So these environments need to be able to deal with intermittent communication, right? And what happens if the user here starts communicating and I lose connection to my database? What happens? Well, I need to be able to cache those gestures and those changes locally. And at some point when network gets restored, I need to reconcile the data that I might have cached in my application. I need to reconcile it with what is in the cloud. So Firebase, right, provides a one place, one-stop shop solution to all these challenges. Right, it's able to very easily implement authentication and authorization, right, where you can easily say, well, these types of users and these types of roles have access to these collections, but not these other collections. Right? And if they're in this particular role, or if they're working from 9 to 5, they have access only during these times or these regions, right? If you're EMEA or Eastern Europe, of Eastern United States or West United States, and by region you have access to these parts of the database. So Firebase has a really powerful expression-based rules, right, that you can establish these kinds of access, which is very, very powerful. It also is able to cache changes on the client, right, as users interact with their local data. Right? If they lose communication, they can then just cache all those changes and then reconcile with the cloud, right, when they reestablish communication, right, and merge changes across. It also supports mechanism where if folks are working in with shared data, right, where we might be looking at or working together on a report for Eastern United States, and you have all representatives in the eastern border, right, working on the same data, right, it can synchronize the data that each user sees, right, so that we can see each other's work and reconcile all the changes that are being sent from the multiple users that are using the same database. So it's an extremely powerful solution that it's very, very popular. It's also very easy to use. So I wanted to demonstrate how would you go about setting it up and start using it. So I'm going to go through some of these slides. First of all, we'll set up a Fire store, a database online on Firebase. And then we'll try to communicate with it using Node.js. Right? So first of all, let's create a Firebase database. So to get started, you can navigate to Firebase google.com. So let's go there. Yeah, so this is the landing page. I encourage you to set up an account and start playing with it. There's tons of documentations and a lot of tutorials that most of it is free to get started, right? And as long as you're within a threshold, right, you can just keep it free. So if you go to the console and you log in, you can get started implementing new projects. Now there is a limit on how many projects you can work on. I believe it's 8 projects. But some of these are just me just playing around. So let's create a project for this section. So I'll call it DB design, SP21, and then 04. Okay. All right. So let's continue. It's going to ask me whether I want Google Analytics. You say sure. And Google Analytics is tied to my annunziato.org account. So it's going to take a minute. I'm just going to set everything up, and it'll create a place for us to start configuring authentication and authorization, create a database, add artificial intelligence. I mean, it's got really, really powerful stuff that definitely is worth exploring for yourself. So let's go continue. Okay, so we have the project. This is the landing page for our project. And it provides really simple scripts that allow you to easily integrate from your iOS, Android, or the web. Right? It gives you just files, a couple of files that you can just copy the content and just drop them into your project. Right? As long as you import them into your project, boom, you're ready to start talking to your online database. So first of all, we'll set up authentication. So this will allow folks to register themselves, right, in various formats, and it has hooks for any number of ways that folks can register and log in. So if you get started, you can choose to just do simple email authentication. You can tie them up with any social network application out there. It has hooks for Facebook, Twitter, Yahoo, Apple, Play, Game Center, Google, phone. And so let's start with email. You just enable it, and that's it. Folks are going to be able to just register themselves with email. They'll get a notification that to verify that that's their email, and they can choose their password, just with their email. And then you can start creating users. You say, well, let's add a user. I'll add myself, so Januzzi at Gmail. And you can set a password. This would be, you as an administrator, you can create some users already, or then folks can then register them on their own. But here you can create a user. So maybe, just choose some bogus password. There we go. Add user. Okay, so there we go. So we've added a user, and all the providers would be listed here, whether it's email or Facebook or Twitter, they would be listed here. Then you can create a database where folks can store data that's specific to them, right? And you can have any number of databases. Right now, let's create one just as an example. You create a database, and at first it'll be offline. You have to turn on the capability of folks to start reading and writing to the database. By default, this is turned off, so that you can just test your application. And once you feel that your data is all set and you want to make it available for everybody, then you can turn this to true. And we'll do that in a minute. But just letting you know that by default, the database is not available for remote use. You need to turn this on to true when you want to make it available for everyone else. So say next. Also, you need to configure where geographically your database should be deployed. Ideally, it will be geographically nearby where your customers or your client or who's going to be accessing your database will be. So I'm going to choose Eastern US. So this is US West. I'll choose Eastern US, say enable. So this is going to create a shared database, right, in the eastern border of the US, right, that we can then access it remotely from our application. So it's setting up the database for us, up and running. And then we're going to be able to insert and data in here. Okay, there we go. So here we are in a graphical interface that allows us to insert documents into collections, right? So for instance, let's start. We'll take a look at a collection that we've been using for the last couple of months, right? For instance, blogs, right? So let's create the blogs collection. And then right away, it allows you to start inserting your very first record, right? Your very first document. You can randomly generate an ID. Right? So this is, again, a unique identifier. Very much like Mongo. If you remember Mongo, right, when you inserted a document, right, by default, it generates a unique identifier. Right here, right, you click the auto ID and it generates it for you. And then here are it's a graphical version of what we did with Mongo, right? In Mongo, we said, db.blogs.insert, and then in curly brackets, we provided the name value pairs. So this is similar to this, right? Here's the name of the field and then the value, the name and the value, the name and the value. And you can provide the data type, the primitive data type for that value. By default is a string, okay? So let's see. So for instance, we might say that the blog has a name, and then the name of the blog might be the space blog, space blog. Okay. And oops, I meant to I meant to have more fields. Sorry about that. Anyway, we can go back here. Notice that it creates the documents, and you can see here the values for the names for the field and the value. You can edit it. You can delete the field, or you can add new fields. You can say add field. So let's add another field, maybe the topic of this blog is space. Maybe all caps, like an enumerated data type. Say add. We can add other things, right? We can say add field. We say maybe how many earning, what's the earnings this year? Earnings. And maybe this is float or number. And it's got $234,000 in earnings. All right, so we've created a document with these name value pairs. Let's create another document. So this time around, let's put all the fields here as opposed to later. Right? We can say let's create another. So again, for the name of the blog, and this is cars are us. Okay, and let's add another field. The topic is cars, and earnings. It's a number, and there we go. Save. So we go. So we got two different documents, right? They're all, well, they're unique identifiers, and the name value pairs for the fields, right? For each one of them. Okay. Notice that like the Mongo, right? There is no schema. There is no declaration that these are the fields for the blogs, these are the data types, right? Instead, each document is free to be whatever they want, right? We might have, for instance, created a document where instead of name, we could have made a mistake and gone with title, maybe the title of blog. Okay, and this might be travel. Travel blog, where the topic is travel. Okay, and save that. So there we go. So we've got three documents, not necessarily all the same, right? Not with the same fields, maybe different data types. Okay, some of them are the same, but nothing is validating or stopping us from inserting whatever we want. Very much like Mongo. All right, everybody good? All right, excellent. So also notice that here we have to add new documents, but notice for that document, we can add more fields, or within that document, we can have a sub document, right? Or another collection under there, right? Like for instance, we might decide that we want to implement something where you have something like this, right? We have copy this. You might have blog as a name and has many posts. So one blog has many posts. And the post might have a title as a string. a little bigger, and that the relationship between the two is that it's a one blog has many posts. Okay. Now, depending on the implementation, right, we might say that the relationship here is that this is a composition, right? And by composition, we mean that if we remove the parent blog, then all the child posts that are related to that blog should also go away, right? Okay, like that, right? And the way you would implement that, the way we saw that we could implement that in Mongo, right, was that we implemented as a sub collection, right, where this would be a collection called posts under the blog, where you would have all the posts for that blog, where one blog can have many posts, right? So this is the field, the title of the post. So this is posts 1, 2, 3, and the content of the posts. This is content 1, 2, 3. Save that. Right. So there we go. So this document is under a posts under a particular blog, right? And you can have any number of posts under here, right? So let's create another one. Right. So this is, again, it has the title, and this is post 2, 3, 4, and has the content, and then content also 2, 3, 4. Right, there we have it. So we have two different posts that live under a particular blog for that blog. So a different blog might have other posts under there, right? And so this is a title. So this would be maybe post 3, 4, 5 with content, right? Content 3, 4, 5. Right, so for this blog, for that blog, we have one post, but for this other blog, we have, oops, cancel. We have two posts. See that? Right, and notice that this implements the aggregation. I mean the composition implementation, right? Relationship. Wait, it's not letting me move this. Why are you not letting me move this? Anyway, it implements a composition because, right, if you remove this blog, all the posts under there are gone, right, which is perfect, right? In a relational database, the way you would implement it would be with a cascade delete. If you remove the parent primary key, it cascades to all the foreign keys records that are referencing that parent record. Right? But they would be in separate tables. Now, you might decide that instead of this implementation, you might decide that instead of composition, for whatever reason, you decide that this be better implemented as an aggregation. You might decide that, no, I don't want that if I remove the blog, I lose all the posts, right? You might decide that a better implementation is using aggregation. Right, and so you might say that means that if you remove the blog, I still want the posts to survive, right? And you would implement it you would document it as follows, with an empty diamond, right? And what this says is that if I remove the blog, I don't necessarily lose the post. They could live on, right? That this relationship is only as a reference. Right, the posts know who the blog is, but if the blog goes away, the post can survive the deletion. So the way you would implement it in Mongo or here, right, is that you would instead have a separate collection called posts, right, where you would have, the title, and this would be, posts 1, 2, 3, right, and content. Like content 1, 2, 3, but you also would have here kind of like a foreign key, right, where you say the blog that you belong to, the blog ID or just blog that you belong to, as a reference, okay, to a particular document, right? Where you would say, I don't know how to reference. This would be blogs, must be a direct, must be collection. So collection would be blogs, document. I don't know the ID. I don't know the ID of the blog that I want. So I'm just going to leave it as a string for now. But it would be the ID, right? Would be some weird ID of the blog that you belong to, right? Would be one of these IDs. Okay, right? And you would have, instead of these posts living under each one of the blogs, they would be all listed. These 3 posts, they would be all listed here, right? This is the first post. Then you would have another document, right, with title. This is post 234 with content also 234. Oh, and the blog that it belongs to, right? Also as well, the blog that it belongs to, again, some weird value. And they will be all listed there. Again, it depends on your implementation, what makes sense for you, right? Whether you want to keep it or not. Sometimes there's a whether it's composition or aggregation depends how you interpret how the data structure should be structured, right? For instance, from a user of Facebook or Twitter, say, right, you might have the mental model that your content belongs to you. So you might think that if I leave Facebook, says I want to stop, I don't want to use Facebook anymore, blah blah blah, I want to leave it, and so you might have the wrong expectation that if you are removed from your database, from their databases, right, that your content is also removed as well, right? That you think that your content is a composition. All the images that you've uploaded, videos, blah blah blah, anything that you've written, you see it as a composition. If I am removed, all that content is also removed, right? But in reality, it might be that the actual implementation, it's an aggregation, right? Whether, hey, if you want to leave, that's fine. We'll remove you, but we're going to keep all the content. Right? So again, it depends, what makes sense to who, looking at it from from whatever point of view, right? And that's an entirely business decision of what it is that you want to do. Okay. So there's no right or wrong answer, right? It's there are no solutions. There are only compromises, right? Anyway, yeah. So we have data there. We have data of blogs and posts. Let's now explore how would we interact with this, right? So we've created our database. We've created some dummy content. Let's see how we could interact. All right. So these slides just walk you through the process that we have just explained, right? We have authentication and creating databases, machine learning. Okay, we're going to first create a database, right? Creating a database, and we deployed it in East US, and here we're adding a couple of collections. We're creating some fields and some values, and we see that we have the collection inserted in there. And so how do we integrate it? How do we talk to the database and retrieve the data? So first of all, there's some documentation. I point you at taking a look at it. But first of all, we need to create an application. Okay. So we're going to click on that. One thing that I forgot to do is here, these rules. See these rules? We need to turn this on to true. True. Okay, this is going to make the the data available outside of this domain, right? So that other folks are going to be able to log in, right, and read and write from outside, right? So we're going to publish this. Okay, all done. All right, so all right, going back here as the slides suggest here in the project overview. In the project overview, we can, in the project that we're in, we can create an application so that we can interact with it and retrieve data. Now you can create it for iOS, Android, or web, right? Or also Unity. Okay, so if we create it for web, you can give it the name of the application, and I'm going to call it, DB design SP21 and 04, and I'll call it app. And you can also host the whole thing in their servers, right? We can just host it on our machine locally. Register the app, and what's going to give us? It's going to give us files, right, and content that we're going to be able to copy this content and paste it into our application, right? This is basically authentication so that our application can authenticate itself with the with Firebase so that they can establish network connectivity. Right, we're going to leave this alone for a second. We're going to come back and copy this. Meanwhile, let's create an application locally on our machine. Let's see, where are we? Let's go to 04. And in here, let's create a directory where we can do all our work, right? So we're going to say make directory. This is DB design. And this is Spring 21, section 04. And this is a Firebase app. Okay. Let's go in there. And so in here, we first, so we're going to use a Node.js. Node.js is a JavaScript interpreter so that we can use JavaScript to code, right? It could be any other language. You can use Python, you can use Java, but JavaScript is one of the easier ways to interact with this. And so let's do that. So in here we can initialize a project. We're using Node as a means of integrating with it. Node has a couple of tools to get started and initialize your project. Right? One of the commands is npm node package manager, which allows you to initialize a project and goes through a wizard asking you what's the name of the project, blah, blah, blah. It basically creates a package JSON file that describes your project. All right, so we're going to open this up with our favorite IDE. I prefer to use IntelliJ, but you can use any. You can basically use any text editor. I'm going to say open, and we're going to go into NEU 2011, 21, 3200. 04, and there it is. That's the application we just created. We'll say open, okay. Okay, so we're here. So we're going to need those files that Firebase is creating for us. Let's go back there. I'm just going to copy the content. I don't need the whole thing. So there's two ways that I can connect to this, either from a React application or JavaScript application running on a browser. Yeah, I can totally do that, and I would copy this entire code. Or, right, I can do it from a JavaScript application running on my desktop. And so this is not a web course, so I'm not going to do the web interface. I'm just going to do it from the command line. So I'm just going to copy this content. That's all I need. So this is personal information for this application. So usually you would not share this with anyone. Right, I'm going to store it here on a file. I'm going to call it, let's see, let me look at my cheat sheet. And I'm going to call it Firebase config.json. Let's do that. So Firebase config.json. And I'm going to paste the content right here. Notice that it's complaining that this is not exactly JSON formatted. It's because JSON wants this to be all quoted. So I'm going to fix that. But other than that, it's all data. It's basically the it's basically our authentication so that our application can authenticate itself with Firebase and say, hey, it's me. You gave me this content, right? So trust me, right? And they can establish a network connectivity so they can exchange data. Okay. Usually, again, this should be private, should not be shared with anyone, right? I'm sharing with you. You know, I'm gonna blow away this this project right after we're done. I'm only demonstrating it for you temporarily, right? So there it is. So Firebase config. The other thing that we need to do is install the libraries that are going to allow my JavaScript application to talk to Firebase. So we're going to install that from the terminal. We install that. Oops, or did I not copy? Copy, paste. There we go. So it's going to download the Firebase libraries and going to copy them into a local directory here, so that we can then link into those libraries and start interacting with the remote database. So that's going to take a bit. So now let's create a file where we can actually implement our application. You can call it whatever you want. Here I called it Firebase, but again, you can call it whatever you want. I'm going to call it app. I'm going to say create new file. This is the app. And so in here is where we're going to do all our work. So first of all, we're going to load the Firebase library that we just installed, right? That we did npm install Firebase. This is how you load it in, right? You require Firebase/app. And then once that is there, you can also load the database, right? So Firestore is the library that allows us to talk to the database. So this is the application, and this is the database, right? Once we have that, we can load up our Firebase configuration. This is the file that contains all the configuration, all the authentication that's going to need it for this to authenticate itself with the remote server. And we load it into a local variable. And then we can use the Firebase library here, right, to initialize our application. Just take the Firebase config, right, and then just initialize the app using that Firebase config. This is going to log us in to the remote database, and it's going to set it up so that we can start communicating with the database. All right, so let's get our first piece of information. Let's grab that. Let's first create the Firestore database. Right, so this Firebase.firestore. This creates the communication with the database, remote database, and it makes it available to our in our local variables so that we can send commands to either get data, retrieve data, update data, delete data. Right? DB will allow us to do all those communications with the remote database. Right. All right. So let's go fetch all our blogs. Right. Let's retrieve all our blogs. Okay. So how do we do that? Well, we do it with db.collection. db.collection. Right. And then we can say what collection do we want to retrieve. In our case, we have a blogs collection. Right. And we also have a posts collection, right? We have those two collections, right? And you get data by saying .get. You say .get. Okay. Now this communication is asynchronous, right? So remember that we had discussed late last week. We said that the communication between applications and remote databases usually happens asynchronously, right? That right, these are processes that are running on separate machines. Right? Firebase certainly is running somewhere in the East Coast. Okay, I don't know exactly where. And my Node.js is running on my rinky-dinky little machine over here. Right? And so that communication can be strained, right? Or could take a while. So what I get back from the database is a promise. I don't know if you remember, we talked about that late last week. That is going to allow us to register for a callback, right? So that when the data comes back, it's going to invoke this function, this callback function, and it's going to provide us the data as a response from the database. Okay, so the data comes back here. We call it a snapshot. Snapshot is a cache or a copy of the remote data, which is now being made available to you here, right? That you can use to read. It also is useful to, if any changes happen, like somebody, right, my colleague changes the title of the blog, I can be notified here. Right? I can be notified that it changed, and the snapshot will capture that. Pretty cool. So for now, I just want to take a look at what came back, right? The documents that came back from the blogs collection, right? So I can take snapshots. Snapshot.docs are the documents, right? That I can iterate over and then display each document. I think I created 3 blogs. No, didn't I? I created, I created 3 blogs. Let's go back to the console. And Firestore. Yeah, I created 3 blogs. Right? So presumably, these docs contains our 3 documents, right? I can iterate over it. I can say for each. So for each iterates over an array and then passes me each document in a function, which I can then display. I can do a console and then display. I can say console log display the document, the actual data. What I call it, doc, right? Well, presumably this is the blog, right? So let's give it its name. So presumably this is the blog, right? And then data actually unwraps the data and prints it out as a JSON object. All right, let's try it out. Let's run this, see if this works. We can run it from the command line. Let's see, from the command line I can say, let's see, we have the app right there. We can run it and say node app. And there it is. I don't know if you can see, right? This is, let me copy the content. Maybe it's too small. Right, this is the data that came back. So this spits out this data. Let me count that out, which is exactly the information that we had in there. See that? It's exactly what we were looking for. Obviously, this, we would want to wrap this inside of a reusable function. Maybe we can call it, const find all blog or something, right? Inside, so this would be a function, and we can wrap this whole thing inside of this reusable function, which I can then invoke, right? I can invoke it with a function. I can say find all blogs. Right, so if I run this, it comes back with that. Yes? All right, excellent. Right? How about something else? How about retrieving a blog, like const find blog by an ID? Right, if I provide a blog ID, this would presumably return that blog ID. So for instance, I would call it something like find blog by ID, right? And I would provide the ID. So for instance, let's see, maybe this blog over here, or this one that has, or this one that has space blog, space blah blah blah, and the ID is K and X KK something like that. Actually, you can see it right here. See that? That's the ID. See that right here at the top? Right. So I can say, retrieve for me the blog with that ID. Okay. So how would we implement that? Well, I have a cheat sheet over here that allows us to do just that. Right, so we can retrieve a blog by its ID. Let me copy this in here. I'm going to paste it in here. So this is for courses. This is another example that I had, right? But here is blogs. I'm retrieving blogs. And this is the ID that I'm passing as an argument. So it's db.collection. They all start with you first saying what collection are you working with, db.collections blogs, and then .doc says this allows you to filter by the primary key, .doc, and you provide the primary key, and then .get actually retrieves the document, right? Makes the network connection, fetches that document, then comes back, and then you can provide a callback. Right? This is the callback where you receive the data, and then you display the data to the console. Okay. All right, let's try it out. Let's run this. And we can run this a node app.js. And there it is, right? This comes back with the document. Let's just display it here, right? With the earnings, the topic, and the name, the space block. See that? Okay. And let's do one more. Say I want to return something by the title or the name of the blog, right? So something like, let's comment that out. Maybe another function, say, const find blog by name, right? Like a where clause, right? Where you can provide a name, right? And you can say like where some field is equal to whatever, right? So for that, I'm gonna copy this. And let's go over that. Oops, again, copy, paste. Okay, so again, it always starts with db.collection and the collection that you want to work with. In this case is blogs. And blogs, right, if we go back to the database, we see that we have blogs. We have one called space blog, one called cars are us, this one called just travel blog. So let's retrieve this one where the name is space blog. So to do that, you say you can establish first the collection that you want to work with, and then .where to filter name, and you can provide a comparison, whether it's greater than, less than, equal, not equal, whatever, right? And then what do you want to compare against? So in this case is space blog. And then .get actually retrieves the data, comes back with a snapshot, okay, and let's put this in a curly bracket. And then here we can iterate over all the blogs that meet that criteria, right? So we're iterating over all the blogs. So this is blog. These are the blog for which we are displaying the particular blog, the data. Okay. All right. Now, presumably we only have one space blog, right? All the one called space blog. So if we run that, okay, we can call it. So, oh, I'm sorry. Name is an argument. So you pass me the name, right? And then I retrieve that particular blog when you pass me the value. So this would be find blog by name, and this will be space blog. There we go. Okay, let's run that. And there it is. It retrieves that one blog as expected. Okay. More more interesting would be maybe by topic, right? That would be cool. Let's try that. It's going to look very, very similar. And this is, blog, refine blog by topic, and then you can provide a topic, and then where a field topic is equal to the topic, right? And let's try that, because I think we have 2 blogs whose topic is space, I believe, right? So this one should return 2 blogs, right? Let's try it out. Terminal, let's run this again. And it returns only 1. Really? Oh, did I? So this one's space blog. This is cars. And this is travel. Let's change this to space. Space. Okay, let's run that again. There we go. Notice that now we get 2 blogs. See that? You can copy that. And those are the blogs for space. There we go. Okay. All right. Excellent. That's all I have for you. Any questions? Anybody still out there?
I'm here. Thank you.
All right. I hope you enjoyed that. I really encourage you to explore Firebase. We only just covered the tippy top of the iceberg, but it's really a great tool to have under your belt, and play around with it. Will definitely look great on your resume. So,
can I ask you a quick question, Professor?
Yes, of course.
What is NoSQL? Like, how does that fit in with all the other different type databases?
Yeah, so there are many different types of databases, but they broadly fall into these 2 categories only because SQL databases have been so dominant in industry, right? So, for quite a bit of time, most databases that have been widely used in industry have been SQL databases or relational databases, which we've spent, I would say, 90% of our course has been relational databases. And they all use SQL as the main way of interacting with the database, right? Select, insert, update, delete, and the SQL that we've covered, throughout the last 3 months. Non-SQL or non-relational databases is kind of like everybody else. All the other databases that don't use SQL, and they're not relational databases, right? They don't split the data in tables and have foreign keys and primary keys, and right. And so under that bucket, you have tons and tons of other types of databases that just plain old don't use SQL as the means of interacting with them. So they'll fall into this broad umbrella of NoSQL databases, of which we looked at 2. The first one was Mongo, of which we had an assignment, right? And you downloaded Mongo and you installed it locally, and you use MongoD and Mongo, and you interacted locally in your database, right? We could have used Mongo also running on the cloud as well. There's quite a bit of solutions where Mongo is running on the cloud. So Firebase is a database that strictly is only on the cloud. It's only meant for being a database as a service. You pay for the service, and you never install it, right? It's only on the cloud, and you interact with it using these APIs. You can look at the data online. You can edit it. You can do whatever you want, right? And then you interact with it using these kind of libraries that I'm showing you.
Thank you. I have some other question that's about your web development class. Can I ask them here?
I need to run right now.
Okay.
But just ping me a little later tonight, and then we can perhaps chat.
Okay. All right. Thank you so much, Professor.
All right.
All right. Have a great day.
Thank you, everyone.
Thank you. Have a nice day.
You too.